Hello class. It is Thursday, April 23rd. We're going to go a little bit further into another topic that the intermediate advanced class, and actually at some point the introductory class, may have to deal with as well. It's a very common problem in robotics when we have to actually hook up something to make some motors drive, to actually make them function. And with that in mind, and being where we are at with being distance learning right now, we're actually going to do this with Tinkercad. Now normally in the lab we would do this with some actual, we do this with an actual motor controller board. We'd have something that looks a little bit different. I'm going to toss up something that we would usually use, which is the Robotics, or an equivalent, in this case they used an L298 motor driver kit. In our case, we're going to be using an L293D Motor Controller. And the difference between these is actually rather simple. This board that's been built, this printed circuit board, PCB, actually has all of the correct circuits on it to actually connect their L298, which is a slightly modified version of this circuit board, into what they're actually doing as far as a project's concerned. We're going to do the exact same thing in Tinkercad, and we're going to use this integrated circuit. Now, a couple things that you guys need to know. This circuit that I've hooked up is based off of the tutorial by codebender_cc on Instructables. I sent that out with the learning plans. I'll post it in the comments for this video as well, because it's a fantastic tutorial. Now it shows the actual integrated circuit, and at one point it actually goes through, and I'm going to drag it onto the screen here, and shows what all the pinouts are. Now when we talk about pinouts, we are looking for this slot on the top of our IC to orient ourselves. We can see that right here, that same slot, along the top of our board. Often in the top left-hand corner there is also a white dot in this case, or an indent in the IC. This is going to allow us to actually lay out what's going on with all of the pins on this particular driver. And we can see that we've got a few things on here that are kind of interesting. And I'm going to decode them for you just so you understand what we're talking about. The first one here is 1,2EN. This is actually an enable pin. It's a pin that's used so that it enables the use of the motor 1 and 2. Likewise, down at the bottom here, we actually have 3, 4 enable. That's going to let 3 and 4 turn on. Now, why would we have a pin to turn something on? Is it not assumed that we're working with this product, we want to use the motors? Not necessarily. We may want to make it so that our circuit can control whether one motor is on at all or off at all. It's kind of like having a power switch on there. For all intents and purposes, though, we want those to be on. So we are going to do what's called shorting them to positive voltage. Now, positive voltage is VCC. In this case, we have VCC1, we have VCC2. And what we're going to do is we're actually going to connect VCC to 5 volts, and then we're going to connect that same 5-volt circuit to both of the enable pins. And we can see here that that's exactly what we've done. We've got our basic circuit here. We're connected to 5 volts. It runs into our first EN, and then it actually jumps across to short the voltage circuit to make sure it is on, and then we short over here to make sure that this is on and our other enable pin is, our other VCC pin is on as well. That allows us to actually connect all of those things and make them run. Now if we go back to the pinout, we see that there's 4 pins in the middle that are all connected to ground, and that makes sense. We've actually done the exact same thing, connected them all to the same ground point on our breadboard, and now we have a motor driver chip that's actually powered. But it doesn't really help if it's powered and it doesn't actually do anything. What we actually want to do here is we actually want to control motors with it. And now, in this case, we have 1A, 1Y, 2A and 2Y, 3A and 3Y, and 4A and 4Y. These are representing the 4 different motors. And in this case, they're actually going to control them. And we've got 2 designations here. We have the A and we have the Y, and in this case we're actually going to see where they're connected. Okay, the A's in this case are actually connected to whether we are activating that motor. And it seems kind of weird though that we've got 1, 2, 3, and 4, but in our actual schematic we've only got 2 motors. That's because this is actually a dual H-bridge chip. And let me just explain what a dual H-bridge chip is, and I'm going to need a diagram for this. So the diagram that I find most useful is actually one that sits on Wikipedia, and we're going to pull that one up as best I can. There we go. This is an H-bridge. This is a single H-bridge. And there's two of these in that chip, or a version of these. How this works is really simple. The circle that you see on the left with the line through it is your voltage. Voltage typically travels in a circuit. And right now, with S1 through S4 being open, we don't actually have a circuit. This motor doesn't turn. But the moment we turn around and close S1 and close S4, in this case using transistors, we're actually going to allow voltage to flow through the motor forwards. This is going to send the motor turning in one direction. Likewise, when we close S3 and S2, we can turn the motor in the other direction. Every other combination of closing these gates pretty much ends up with a short circuit of some sort or a motor that doesn't work. For example, if we closed S1 and S2, we get electricity that just flowed by the motor. It was never in series. Now, each motor has two different pins controlling it. And in this case, that means that one pin, when turned on, is going to activate S1 and S4 and turn the motor in one direction. The other pin, when it's turned on, is going to close S3 and S2 and turn the motor in the other direction. We have two of these on our motor, or on our chip, which means that we can control two motors at a time. And that's kind of what we see here. If we go back to the schematic, we actually have the ability to hook our 3 and 4 wires into our actual motor. That's exactly what we've done. We've got each motor has two of those wires connected in here, and two wires here and here controlling it. Now, the reason this is the next video is because we talked about digital logic. We talked about digital ons and offs, and the funny part is the way this motor is hooked up right now uses nothing but digital ons and offs. I'll show you what I've got right now. I've actually put some code into this one based off of the same tutorial, and right now when I start my simulation, you see that I get a full forward motion, 143 RPM for 1 second, 2 seconds in one motor, and then backwards, forward, and then backwards in the other motor, and then they both turn off. But how did we do that? Let's walk through it. If we click on our code, we see a lot of code. And what I'm going to do is I'm going to grab this, and I'm actually going to go over to a new Arduino window where I have my font size cranked way up so you can all see it. We're going to paste this in here. Now, once you've got your code built and you're not sure if everything's lined up the way it's supposed to be, sometimes a good idea to go up to Tools and click Auto Format. You'll notice that some of my stuff moved around. Everything that's indented because of the auto format is indented because it's inside of a loop. So in this case, all of our integers and all of our variables that are declared at the start of this routine are all basically left aligned. They're along the left-hand side, as is our void setup. They're all at the same level. But everything that's inside the setup, it gets popped over a little bit. This becomes more important when we start to nest things within if commands and whatnot. Now, we notice right off the bat that we've got nothing in void loop. We just got an empty chunk of code right there. And that is going to actually, that's actually going to not function, not do anything, because everything we're doing is only going to function once. That's what setup does. And before that, we need to set up some motor pins. So let's walk through. What you recognize here is the int, integer variable, and we've named it motor pin 1. We've made it equal to 5. We put a semicolon on it. That all makes pretty much sense. But before that, we've put the word constant, okay? Constant in this case means that that variable is not actually meant to change throughout the course of this code. It's actually something we could have done in our previous tutorial where we talked about LEDs, where we talked about the idea of putting a push button. We could have used a constant variable here. And I know that's an oxymoron, but in coding it kind of makes sense. So this is always going to be pin 5 for the rest of the code. If we ever change it, we're going to re-upload this code, so we can actually use this designation. We've got 4. Pin 5, pin 6, pin 10, pin 9 for motors 1 through 4. And if we look back at our motor controller here, we see that we have motors set up on, pin 9, 10, pin 5, 6. That checks out. No problems there. Now that we've got that, let's walk through what this does. First, we set our pin modes, all of them as outputs. That makes sense. They're all controlling motors. They're not going to receive sensor data. If we had sensors in this circuit, we would add that. Then we go to the next part of the code. It says this code will turn motor A clockwise for 2 seconds, which is actually what we saw when we were looking at the motor. And it's very simply 4 digital write commands. In this case, we got digital write motor 1 high and the rest of them low. This is going to activate one of those motors. In essence, it's turning that S1 and S4 on one of the motors to turn forwards, whereas it's not turning the other direction. It's actually turned the other motor off because the other motor would be controlled by pin 3 and 4. We then delay for 2,000 milliseconds. I'm actually going to modify this because we have the ability to use variables. I actually want to be able to change the timing on this. So I'm going to go create a new integer and I'm going to call it timer. I'm not going to make it a constant integer like the rest of the variables here because I want this one to change potentially if I want to change somewhere in my code. I'm going to make it equal to 1 second just because I want to test this out. And then I'm going to go back into my code. Every time I find 2 seconds, I'm just going to replace this with the variable timer. And now this is only going to move for 1 second. Likewise, we can move motor A counterclockwise for 2 seconds by turning the second motor low and the rest, or sorry, second motor pin low and the rest of them, sorry, second motor pin high and the rest of them low. And likewise with the other motor by turning pin 3 and pin 4 high with the rest of them staying low. Lastly, we turn everything off. This is usually a good idea whenever you're doing any kind of code. Now, that's exactly what we saw. We just used a digital write. I'm going to swap out my timer command here just to show you how this works. And it's basically going to allow you to move all of those motors. And notice there's no delay at the end of this. This is our last command, so this is where the thing should end. This is where the code ends, so we don't really need to delay because nothing else is going to happen. Once we take all of this, we should now get something back in Tinkercad whereby we paste this in and we confirm, yeah, my timers are in there, my new timer variable's there. I'll close my code down. We're going to check out if this works. Now, if I'm your teacher, and there's 1 second each, very fast 1 second, and you want to show me how this works. How might you do that? Well, a question that I might ask to show that you understand how these work is I may have you change the actual pin on one of your motor controller pins to a different pin and change the code to match. Or I may have you actually change the amount of time between each of the motor movements. Or we might have you combine motor movements. That'll be another topic for another day though at this point. I hope you learned a few things about the motors and how they function with the L293D chip, and basically how to make this whole circuit function. Cheers, and we'll see you in the next one.